Hello guys, I'm back. In this video, I will share with you some comments related to pressure control. What kind of observation or issues you should evaluate when you are doing the sizing selection of a pressure control valve in your system. My name is Jeferson Costa and I teach students, graduates and engineers how to work with chemical process engineering and plant design. Follow my profile and like this video to get hundreds of contents related to chemical process engineering and plant design. Today I had a discussion with the operation director about the need or the possibility of removing a booster compressor from one of the projects that we are dealing with. And during the discussion, I shared with him what it would be not possible or why it was not recommended to remove this booster compressor. And that was based on the operating pressure control that we have to the current system. So in this video, I will share with you here just as an example to help us to understand my point here, a PNID from a temperature swing adsorption. So you can see in my screen two vessels, and while one is online, the other one is in the regeneration mode. And here I have a heat exchanger able to heat the purging gas, and with that do the recycle the regeneration at high temperature in the temperature swing adsorption, TSA. So what was the main issue? I needed to keep a pressure in my temperature swing adsorption vessel to guarantee the performance of this equipment, because it depends not only in the temperature but also in the pressure of the system. So to be able to do that, in the bottom of my PNID, I have a pressure indicator transmitter that sends a signal for the pressure valve or the pressure control valve PV404. So what is the function of this PV404? Is to keep a constant pressure upstream of the valve. So my biogas comes from the bottom side, enters at the bottom of the vessels and goes through the up. And when I have a decrease in operating pressure in this side here, my control valve will close. If I have an increase in the operating pressure, my valve will go up, will open. So what is the concern that we was talking about? Every time that you do plant design as a chemical process engineer, you do the calculations based on the design conditions, that is the nominal production that you are looking to achieve. So let's say that you need to produce 1,000 normal cubic meter per hour of hydrogen. So this is your design conditions. And you will perform the process simulation based on that and perform all the calculations based on that. But the plant do not run only at the design case, because it's depending on a lot of circumstances, the market, if we need to have turned down or not, how many machines are available. So most often, besides the design point, you need to consider what is the minimum flow required to have the production of your process. As low as you can go to the production without stopping the plant is better, but in the other hand, you will not reduce in the same proportion the OPEX or the electrical power required to do the production. So when you design a plant at design conditions and you run your operations at lower rates, most often it means that you are expending more energy to produce the product, and the KPI will be lower, and with that it's not good for the profits of the company. Why I'm telling you that? I'm telling you that because this control valve here is designed or is selected, sizing selected to have a specific pressure drop during the design conditions. So if I am with 100% capacity, for instance, I will have here 0.5 bar as a pressure drop. This is just for example. But if I decrease the capacity of my plant from 100% to 50%, if the machines, rotating machines and static machines allow us that, it means that I will have less flow, and because of that, my valve will need to close more to keep the same pressure down upstream of the process. And because I reduce the orifice for my control valve, it means that the pressure downstream of the control valve will be lower, because as I reduce the orifice, I increase the pressure drop, and because of the pressure drop variation, the control valve is able to do the controlling. But that impacts the downstream of the control valve. So if I have a compressor, for instance, or any other process that relies on the pressure that comes from this control valve here or from this process, I must to make sure that this control valve will have a pressure drop that fits for the design condition, but also fits for the turn down conditions. So I need to know what is the variation in the pressure drop when I am in 100% of capacity, and also when I am in 50% of the capacity, 75% of the capacity, and etc. So if it's your responsibility to do the sizing selection of this control valve, you must verify what are the influences that will lead to the variation of pressure down upstream of your control valve, and what will happen if with the variation in the pressure downstream of your control valve, in order that you guarantee the operations and also the performance of your plant. If you want to know more about control valve sizing and selection, take a look in this video that will appear to you right now. Share this video with students, graduates, and engineers in order to help me to achieve more people around the world. This is it, guys. I hope you like it, and I'll see you soon in the next video. Bye bye.